Alright guys, I got some help on this and I think I understand it a lot better now. I made a new problem for one that's, I think, a better example than the one they have in the book for us as a homework problem. So this says 5 weighted coins are tossed simultaneously and the probability of a single weighted coin landing face heads up is 60%. So these 5 coins being tossed, they are all independent events. We can describe getting face up as success and getting tails up being failure. Therefore, when we start talking about our first problem, which says what is the probability of getting 4 heads and a tail in any order, you got to keep in mind that what we're talking about is getting heads, 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 tails, or some kind of different order that's going on here. And it doesn't really matter the order once again, as long as the situation has 4 heads and a single tails. Us getting 4 heads will be considered success. All right, success. I am choosing to get 4 heads being deemed as success. Okay, so out of my 5 trials, which means that's the 5 coins being tossed, out of my 5 trials, okay, my probability being 0.6, once again, this is referring to getting heads face up, and then my x, since I am going to decide that having 4 heads is considered success. So when I go to my formula, p of x equals 4, I have 5 choose 4, which means out of my 5 trials, I'm choosing 4 heads. My probability of success is 0.6. And once again, that probability of success is for each individual heads. That's why I'm bringing it to the power of 4. Now, there's a chance of failure. As we know, we have success, which is getting the heads, or it could fail and we get tails. Well, since our probability for success is 0.6, therefore the probability of failure would be 0.4 because it's 1 minus 0.6. And this is raised to my x, my 5 minus 4, which is 1. Now, in the formula, you just feel like, oh, it's the numbers, 5 minus 4. I'm supposed to always subtract there. But what that number is really representing is your failure. So if this is for successful at 0.6, this is 0.4, my 1 failure. When I'm tossing those 5 coins, getting a heads, a heads, a heads, and a heads, those are my 4 successes. That's why I have 0.6 to the 4th. But once again, I'm supposed to also get 1 tails. That's a failure. I wanted heads. I'm testing for success in heads. And I didn't get that last one, hence the failure of 1 power, which is why it's 5 minus 4 is what we normally put there when we follow our formula. So now when we go ahead and do our factorials of the 5 choose 4, and we get 5 when we plug into our formula, 5 factorial over 4 factorial. And then once again, 5 minus 4 is 1 factorial. When we work that out, we're going to end up with 5 times 0.6 to the 4th, which is our success, times 0.1, times 0.4 to the 1st. We calculate that out, we're going to get 0.2592. So as a decimal, that is, as a percentage, it's going to be 25.92%. I want to look at this exact same question, but I want to flip it. This time in the problem, I'm going to decide that the probability, that I'm going to ask what is the probability of getting 4 heads and 1 tails. But this time I'm going to define success as getting 1 tails. I'm defining success as getting 1 tails, which means tails probability, as we saw here in red, is 0.4. And my x this time is going to be 1, because I am deeming getting a single tails as success. So if I do the probability of x equals 1, where I have my choose 5 of 1, so this is my binomial coefficient, times 0.4, once again, we're going to take the number that I'm trying to get success for, which is 1 time, because I just want 1 tails. That means my failure, which is the probability of heads, to the 4th power. Because if I'm defining success as 1 tails, this is success. The other 3, or actually other 4 that are heads, are failures, which is being represented by that 0.6 to the 4th power. When I calculate this out, when I do my coefficient here, when I do my binomial coefficient, once again, I'm going to get a 5 here. I'm going to get 0.4 to the 1st times 0.6 to the 4th. And once again, that calculates out exactly what we had before. And that's because you're going to get the same thing no matter how you view the success. So in class, if you used 4, because of the 4 heads, you defined heads as getting 4 heads is considered successful. That means that last little slot, that 5th coin, it turned tails, as it said here in our little story, which means that's your failure. That's where the 0.4 to the 1st power is coming from. So let's take a look at the one below. So let me clean this up a little bit. Made a bit of a mess for us. All right, so looking at our second one, it says, what is the probability of getting 2 heads and 3 tails in any order? So since it's in any order, it doesn't matter which way we do it. All right, so for our next problem, it says, what is the probability of getting 2 heads and 3 tails? So the number of trials is 5. And this time, I'm going to define success as getting 2 heads. And therefore, 3 tails will be considered failure. So probability of getting a heads is 0.6. My x will be 2, because once again, I'm defining success as getting 2 heads. So I will have the probability of x equals 2, where I have 5 over 2 times the probability of success, 2 times, because 2 heads, times my probability of failure, which would be 0.4, and 5 take away 2 is 3, which is getting 3 tails, which will be considered failure for us. Go ahead, I do this calculation in my calculator, 5, 2, that's going to give me 10.6 to the second, 0.4 to the third. When I type that into the calculator, it's going to give me 0.2304. Now I'm going to go ahead and I'm going to look at this in terms of tails, where I'm going to define tails as success. And I'm going to determine getting a heads as failure. So once again, number of trials is 5. Probability is 0.6. And this time, my probability, my x for success is going to be 3 because I'm defining it as 3 tails. So the probability of x equals 3. It's still going to have the 5. Now 5 choose 3. And the probability of success for a tails is 0.4. And I'm looking for 3 successes because of 3 tails. And my probability of failure with 2, which once again adds up to 5 for my 5 trials. 5 over 3, do the math, we're going to get ourselves a 10. We got 0.4 to the 3, 0.6 to the second. We type that into our calculator, we're going to get 0.2304. And once again, you can see the probability is the same. It's all about what you're choosing to define as success and what you're defining as failure. Our last one here on the bottom is a little unique, and that's because it's not giving us a choice. You may notice earlier these problems said in any order, So this 5, this 5, this 10, this 10, it's showing all the different kind of combinations you could have with those heads and tails and whatnot. So here it tells us what is the probability of getting 4 heads and then 1 tails. It has locked us in to having to get heads, 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 and heads, and then the last one to be tails. Now I'm going to go ahead and define heads as success. Since I'm going to define heads as success, I know that the probability of x equals 4, and the probability of success is 6 to the 0.6 to the 4th power, and my probability of failure is just going to be 0.4 to the 1st. You'll notice this time I didn't need the binomial coefficient, and that's because they've locked me in to one exact order. And since it's one exact order, and I can't have any variation in that, I don't have to try to figure out all the probabilities of all those combinations, which is what this 10 here, this 10 here, and this 5 are doing for us. We got one order we're allowed to be in, therefore you don't even need the coefficient, but if you want to put a 1 there, you can. So now we just type this into a calculator. We have 0.6 to the 4th times 0.4 to the 1st, and we get a probability of 0.05184, or about 5.184% chance that we get 4 heads and then a tails in that probability. I hope this video has helped make it understand a little bit better. It makes a lot more sense to me. Hopefully this helped. If not, we're going to spend more time on this on Monday as we start to prep for the test.